All right. Okay, so what we are going to be talking about is linear equations. That's pretty much what this is all about. Right, so there's going to be graphing and there's going to be some solving included in this, but let's just talk about what the heck a linear equation is. Anybody know? Anybody remember? Yes. Okay, so linear equation, so it can be written, I'm sorry, my writing's gonna be sloppy. It can be written in the form ax plus by equals c. You guys remember that? Remember what this form is called?
This is the one with the guy feature, right?
Yes, Mr. Turpin talked about this. What is this form called? Standard form. All right. So in this form, there's a few things, all right, about linear equations. Okay, our variables are x and y. All right, on these variables, our exponent is 1. It is always 1. You're not going to have a y to the second power, or an x to the second, a third, a fourth, a fifth. Our exponent is always 1. So when you see an exponent of 1, it's usually not written, right? It's there though. These are both exponents of 1. All right, so x and y are variables. Exponent is 1. Oh, there's one more thing about that. In a linear equation, there is no dividing of variables. So you're never going to have something divided by x or something divided by y. And there is no multiplication between variables. So you won't have x times y or y times x or anything else. Again, sorry for my handwriting. It's just not easy. All right, so that's when we need to talk about x and y. Those are our variables. They're going to change, things we need to solve for. Now let's talk about A, B, and C. They are numbers. Okay. C is called a constant. That's because it's a term that has no variable with it. So right here, this y term, we call this a y term because the variable is y. B is not a constant because it's being multiplied by a variable. So this is going to vary with the variable. Same with our x term. Our A is going to vary with our variable. Multiplying by x is going to change that value. C is not being multiplied by anything. It's just going to stay how it is. All right, so with this, we got some rules. Both A and B are not 0. What do you think that is?
Wait, how could they not be 0? Because I saw problems in the homework where it said x plus something y equals, you know what I'm saying?
So both A and B can't be 0. So that means at the same time.
So it could just one could be 0?
A could be 0. If A is 0, B can't be 0.
So
if B is 0, A can't.
X plus y equals 7 because 0 plus 0 equals 7. It's not possible.
Yeah. So if A and B are 0, we have A times x.
So 0 times x is 0 plus 0 times y is 0, so it can't equal anything.
Yes. And then we have 0 plus 0 equals 7. 0 equals 7. That's not true. Okay. So that's why A and B can't both be 0. All right. So also with linear equations, so when we talk about linear equations, they always look a certain way on a graph. Okay, so let's label this graph quick. This line here, this horizontal line, what do we call that? That's the x-axis. Okay, so if we're going to label it, this would be 1, 2, 3, 4, going positive, right? So if we go to the left, we're going negative. So -1, -2, -3, and so on. All right, this line going up and down, this vertical line, what is that called? That's our y-axis. So all of our y values are there. So going up is positive or negative? Positive. So +1, +2, +3, and so on. And if we go down, we're going negative. So -1, -2, -3. All right. So if we are talking about a linear equation, this one. A linear equation always is a line. Okay? And it's going to continue in both directions. So notice how I have an arrow at the end here and an arrow here. It's saying that that line is continuing on forever. So that's what a linear equation looks like. It's always going to be a line. All right, and so how many, question for you guys, on a line here, how many points are on that line? We got a point here, we got a point here, and here, and here. How many points can I make on this line?
Infinite?
Infinitely many. So a line is just a set of points, okay? Just made up of infinitely many points. So what this line is representing are solutions for our linear equation. So if we look back at our linear equation, we've got two variables, x and y. Okay, so our solutions for our linear equations, you have an x value and a y value. If we think about a point on a graph, it's an x value and a y value. So each point is a solution to your equation. There are so many solutions, right? There are infinitely many that are going to work for a linear equation. That's why we just draw it as a line. You can just pick any point on the line, and you take those numbers, plug them in here, and it'll be a true statement. It'll be a true equation. It'll be a solution to your linear equation. All right, so that is linear equations. Any questions on that part? All right, so let's talk about determining if something is linear. So what if I have 1/3 y equals 7? I'm going to write down a few different equations. So, will someone near you decide whether each of these is linear or not? Remember what a linear equation is. Figure out which are linear and which aren't. So that means I want you to talk to someone that you're sitting near and decide which ones are linear, which ones aren't.
What do you think? I think 2 is linear. Oh, I thought that was a 2. I didn't think that was a 2. So then, I don't think any of them are then. Maybe 4 and 3. I think maybe 4.
All right, what do you guys think? What about number 1? Is that linear or not?
No.
Au contraire, it is. All right, so
It is?
a linear equation can be written in standard form, right? So that's ax plus by equals c.
where's the AX?
So my value for A must be 0 here.
So there's no X?
I know, what's 0 times X?
Nothing.
0, so it just wouldn't show up.
Okay, well that's X.
Alright, so this is linear.
Okay, well that's.
Alright, so if you can write the equation in standard form, then it's linear. Alright, let's look at number 2. Is that linear or not?
No.
No. Why is that?
Because there's an exponent.
There's an exponent of 2. Okay, an equation like this is called a quadratic, and we will talk about those later in the year, hopefully. Those look like a curve, so that's not linear. That's not linear. What about number 3?
Yes.
Yes, I can write that in standard form. Right? I can know I know stuff about moving things around, so I can move my 2x to the other side by my y. Those would cancel, and I've got a negative 2x, right? Minus 2x plus my y here
Switch sides?
equals negative 4. So when you were solving equations, right, you were moving things from side to side. Like, I want my x's on one side, so I'm going to move my x's over here. That's what we did here. We just moved our x's over our y's, because that's what standard form looks like. And then we're left with a constant on the other side, just a number. So this is linear. All right, what about number 4?
No.
No, why not, Noah? It's x y. Yeah, we got x times y. All right? In linear equations, your variables aren't going to multiply. So this is not linear. All right. So now let's talk about graphing these. So I'm going to get the graph up here somehow, some way. Just so you guys know, I can't read what's up there, so I'm just doing my best. I should have maybe had an actual picture on here. Alright, so while I am drawing this out, can someone look at their 3-1 worksheet and pick one of the linear equations on there for us to graph? I'm going to get this drawn.
Okay, you want one?
Just a sec.
You just want a random one, or do you want one that's linear or not?
I want it to be linear, for sure. Alright,
You want it now?
yes please.
2x equals 4y.
Alright, so this is linear, right? We can write this as, we can put our 4y on the other side. And we have 2x minus 4y equals what? 0, right? Because these cancel, and we're left with 0. Alright, so that is a linear equation. Alright, so this is a way we can graph linear equations that's always going to work. Always. Alright? We're going to use a table of values. You guys remember a table of values? So we have x here and y here. Remember this? So how do I fill out a table of values? How do I fill it out though? What do I do?
You have to write like a number, like on x, like say 1, and then
Okay, so we'll pick 1 for an x value.
y would be 0.
Would it be?
Well, if it's like the.
So if we put in a 1 for x, what we're doing is we're saying, okay, I'm going to put x equal to 1. So that means now I have 2 times 1
Oh, that would be 4.
minus 4y equals 0. And then we solve for y. So 2 times 1 is 2, minus 4y equals 0. I gotta get rid of this positive 2. I have negative 4y equals 0 minus 2 is negative 2. And then I divide by negative 4 on both sides. Let's cancel. I'm left with y equals, what's negative 2 divided by negative 4?
Negative.
Nope, it'll be positive. Negative divided by negative is positive.
Positive 2, positive 8.
2 divided by 4.
Yeah, it's positive 25.
Yeah, so 1/2. Or 0.5. Okay? So that is my y value here then, 0.5. All right, what's another value we could put in for x?
2.5.
A trick for doing your tables, pick numbers that are going to be easy.
Okay, 2.75.
Let's do 2. All right, so now if I put in 2 here, oh, come on, where's my eraser? There it is. Oh, man. Still getting the hang of this, guys. All right, so if I put in 2 for x, 2 times 2 is 4, so now I have 4 minus 4y equals 0. I need to get this 4, it's a positive 4, so subtract 4 from both sides. Can you stop clicking your pen, please? Sorry, I'm just with recording it, I don't want it to be any extra noise. So we cancel, I got negative 4y equals negative 4, so what does y equal?
0, 1,
1.
Yeah,
So when x is 2, y is 1. Alright, so we can make a line with 2 points, but just to be safe, let's do one more. Should we do negative 3? Should we get some negative values in here?
No.
I think we should. Let's do negative 3.
That's weird.
Okay? I highly recommend that when you're doing a table of values, you do some positive and some negative numbers so you get values on both sides of the x-axis. Okay. So, x is now negative 3. What's 2 times negative 3? Negative 6. Negative 6 minus 4y equals 0. I got a minus 6, now I'm going to plus 6. Plus 6. Those will cancel. I got negative 4y equals 6. Divided by negative 4. So y equals what?
1.5.
Yeah. These can reduce by dividing by 2. So that's 3 over 2, which is negative 1.5. All right. So now we have a table of values. What do we do with these numbers? Yeah. So what do you mean graph them? All right. So then Noah, tell me what's my first. Tell me what to graph. Let me get this. All right. What should I graph? 1.5.
1 on the x, and then 0.5 on the y.
Yeah. So each of these rows is a point on the graph. So point 1, point 5. So that's about there. All right, you go 1 on the x value, 0.5 in the y. Okay, then this is the point 2, 1. So 2 on the x, 1 on the y. And then this is the point negative 3, negative 1.5. So we go negative 3 on the x, negative 1.5 on the y. So obviously this isn't going to be perfect because I drew my graph. I have graph paper, so if you guys want graph paper at any point,
Yes.
there's a whole stack right in front of the corkboard. If you want it right now, you can go grab it. Okay? So now we have these points. Use a straight edge to connect them, okay? That way it's a straight line. Obviously, I'm going to get a straight line here, but my points are messy because I don't have an actual graph. Also, at the end, that's really bad. I'm so sorry, guys.
That is really bad.
Yeah, but make sure when you draw your line, you put arrows on both ends. Okay? So that's going to tell me you know that this is going to keep going in both ways.
Infinite.
Infinite, yes. All right, what do you guys think about that? Not too bad? You guys have done this before?
It makes
Table
more sense
values?
now.
What was it?
It makes more sense now.
All right, so let's talk about another way of graphing these equations. All right, I'm gonna put
a
it.
linear equation.
Yeah, I appreciate that.
Algebra.
Thanks. I appreciate it. Yeah, next time I'll make sure that I have the graph on here. Oh, they're all negative. Because, yeah, this is a little bit of a pain. Live and you learn. All right.
4x minus 2y equals -1.
Perfect. All right. So the other way I'm going to talk about this with graphing is using x and y intercepts. What do you guys remember about x and y intercepts?
That is where it goes over the axis. Like an x-intercept is when it goes over the x-axis, and a y-intercept is when it goes over the y-axis.
Yeah. So if you have a linear equation, oh, that was not a good. Okay. If you have a linear equation, it's just a line. It's going to hit the y-axis once and the x-axis once. At least one of those. Okay? There are instances where you won't hit one of the axes, but you'll always hit at least one. Okay? So our x-intercept is where the line meets the x-axis, and our y-intercept is where the line meets the y-axis. Not too crazy. All right, but there's a certain little piece that we need to understand in order to use this to graph. So, if we look at our x-intercept here, what do we know about our y value at that point?
It's negative,
Is it?
or it's 0 there,
It's 0, right?
but it's negative, the y-axis.
The x might be negative, but if we drew this line, our x is positive. But our y value is still 0. So our x-intercept, it's always on the x-axis. Well, every point on the x-axis, y equals 0. So then if we look at the y-intercept, what do you think our x value is?
0.
0, right? We aren't moving positive or negative x. We're staying right in line with the origin. Right? The origin is that point in the center of our coordinate plane. All right, so for our y-intercept, x is 0. We can use this then, that was a terrible circle, to graph, to find these points. All right, so let's first find the x-intercept. Okay, for the x-intercept, y equals 0, right? So in this linear equation we're trying to graph, put y as 0. We have 4x minus 2 times 0 equals -1. What's 2 times 0? 0. So really, I just have 4x equals -1. Divide by 4 on both sides. I got x equals -1 over 4. Or that's -0.25. So what that means is for my x-intercept, the x value at that point is -1 over 4. The y value, what's the y value? 0, right? We already said y is 0. And then I can graph that point. So let's get a different color in here. So -1/4. I realize that's really small there. So that is a point on our line. For a line, we need 2 points, right? So let's find the y-intercept. That'll be another point. For the y-intercept, x is 0. So then in our linear equation, we put x as 0. What's 4 times 0? Yeah, so all I really have is -2y equals -1. Divide by -2 on both sides. I got y equals, what's negative 1 divided by negative 2? Will it be positive or negative? Positive. It's the same sign. So our answer is positive, and we have 1 over 2, which is 1 half. So then the point, we know our y value is 1 half. What's our x value? 0. Now we put that point down here. 0, 1 half. And then what we can do is get a straight edge and put the line through those 2 points. And we've graphed our equation. Alright, so at this point, is there any questions on table of values or x and y intercepts? Is this making more sense now? Yeah. Teaching online sucks.
Yeah,
Can't imagine how learning online is. Sucks. I bet it does. Alright, but we both gotta put in effort, right? This is gonna even work at all. Alright. So now, that was like pretty much just a 3-1. Okay, so your 3-1 worksheet should be not too bad now. Okay? So now let's talk about 3-3, which was slope. In the video, I talked about rate of change, because I thought that might be something you've heard of. Who's actually really heard of rate of change? You've heard of it. So you're kind of, it sounds familiar.
I think we know just a tiny bit of Steinbach's cost.
Yeah. So what I'm really concerned about is that you guys understand what slope is. Right. So, oh, you stupid thing. Alright, so slope. Who remembers what slope is?
slope is,
If,
Noah?
it's something to do with the y-intercept, something like that.
Nope, not
it's
with
the
the y.
height and the base.
You could think about it like that if you're thinking about on a graph. Yeah, Ethan?
Changing y minus changing x.
No. Okay, so a slope, it's the steepness of the line. Okay, that's what slope represents. Alright, so our linear equations are lines. Some are steep, some aren't so steep, right? If you look at them on a graph. Like if you think about this graph, this line is pretty steep. This one, not as much. Each has a different slope to the line. Okay, for slope, the variable we always use is n. Okay? And what slope is, it's the change in y between 2 points over the change in x between 2 points. So if our 2 points on a line, if they are x sub 1, okay, that's how we say that with x with a little mini 1 after it, and y sub 1. So this just means point 1, point 1's x, point 1's y, and another point x sub 2, y sub 2. Our slope is the change in y, so we'll do y sub 2 minus y sub 1 over the change in x, x sub 2 minus x sub 1. Alright, so if our points are 1, 2, and 4, 6, we want to find the slope of that. We take the changes in our y's, so we do 6 minus, okay, so 6 is a y value, 2 is a y value. 6 minus 2 over 4 minus 1. And we solve. What's x minus 2? That's 4. 4 minus 1 is 3. So our slope is 4 over 3. Another way you might see slope written or talked about is rise over run. Alright, so let's just kind of talk about it on the graph. So I'm just going to look at the first quadrant. And I'm going to put in some grid lines that are just terribly drawn. I'm so sorry, guys. need to think farther ahead. All right, so if we have 2 points of a line, okay, if those are our 2 points on a line, and say we're even given the line, let's draw in the line. We need to find the slope of that line. Our rise, what are we talking about with our rise? That's our change in y, right? Our rise is going up and down. So this right here is our rise. Are we going up or down? Up. How many are we going up?
2.
2. So our rise is a positive 2. Our run, we typically do our run left to right, like this. Okay, so how many am I moving? 1, 2, 3, 4, 4. So my run is 4. So to find my slope, I put my rise of 2 over my run of 4 and then reduce. So my slope for this line is 1/2.
So you could think of it as height and base.
Yeah, so if you look at going from one of our points to the next, we make a triangle, right? We make a right triangle. So you can think about it as your height over your base. Right? My rise is my height, my run is my base. Wait, what's going on?
What the heck?
About it.
What is it?
After 40 minutes idle time.